Example 1, using the first derivative test. So we're going to use the first derivative test, which is what we talked about in the last video, with all those different examples of how the derivative is going to tell us how the function's behaving to determine the local extreme values. Then we're going to identify any absolute extrema. So here we have the graph x cubed minus 12x minus 5. So when we use our second derivative test, or our first derivative test rather, we are going to need to take the derivative. So let's do that. We take the derivative, we get f prime of x is equal to 3x squared minus 12. Then what we want to do is set the derivative equal to 0. So you get 0 is equal to 3 times x squared minus 4. And you get 0 is equal to 3 x minus 2x plus 2. And solving, you get x equals 2 and x equals negative 2. These are going to be our critical values. These are our critical points. So with the first derivative, we've been actually doing this for a while, is making the sign chart, but we're now going to simplify that sign chart just a little bit. I'm just going to draw a bar. This is going to represent f prime of x. And I'm going to list my critical values here, negative 2 and 2. So from here, we need to determine values on each side of it. So I'm going to choose negative 3, 0, and 3. Those are my values that I'm going to test. So then we just plug these values into the derivative, and you get f prime of negative 3 is 3, negative 3 minus 2, and negative 3 plus 2. And notice I'm plugging them into the factored form because I don't actually care what the value is. I just care that if it's positive or negative. So let's look at this. Right here, that's positive. This piece is going to be negative, and this piece is going to be negative. So a positive, a negative, and a negative is going to result in a positive. So from negative infinity to negative 2, the derivative is positive, giving us that the function is increasing. Now we need to pick a value in between negative 2 and 2. And that's where we're going to choose 0. So f prime of 0 is 3, 0 minus 2, 0 plus 2. Now this is positive. This piece is going to be negative, and this piece is going to be positive. So altogether, this makes a negative. So from negative 2 to 2, we have negative. And now we need to check our last one, which is f prime of 3, which gives us 3, 3 minus 2, 3 plus 2. This piece is positive. This is positive. And this is positive. So if everything is positive, we get that the entire function is positive. So the derivative from 2 to infinity is going to be positive. Now just looking at my arrows, you can kind of tell where the max and the mins are going to be. So now what we need to do is we need to determine the values. So to do that, we're going to take these values right here and we're going to plug them into our original function. This is going to tell us what the y value is at that x value. So f of negative 2 then is negative 2 cubed minus 12 times negative 2 minus 5, which gives us negative 8 plus 24 minus 5, which gives us 11. F of 2 is equal to 2 cubed minus 12 times 2 minus 5, which is 8 minus 24 minus 5, which gives us negative 21. So now we've got all of our pieces, and now we're going to draw a conclusion. We're going to determine whether at negative 2 we have a min or a max, and same thing for 2. So, here's our conclusion. Since f prime of x is greater than 0 from negative infinity to negative 2, and f prime of x is less than 0 from negative 2 to 2, we get that 11 is a local max at x equals negative 2. So because the derivative is positive and changes to negative, which means the function goes from increasing to decreasing, then 11 is a local max at negative 2. Since f prime of x is less than 0 from negative 2 to 2, and f prime of x is greater than 0 from 2 to infinity, then negative 21 is a local min at x equals 2. Now, a word of warning, just because 11 is larger than negative 21 does not mean, that's not the reason why that 11 is the max. It's because of the derivatives. Alright, now we're going to look at a little bit more of a complicated function, because this one is just a cubic, so we know this thing generally looks like this. We're going to look at something a little more complicated. We also need to know where the absolutes were. Since the domain is negative infinity to infinity, there are no absolute extrema. Alright, moving on to part B. G of x equals x squared minus 3 times e to the x. A little more complicated function, just makes it a little more fun. So the first thing we need to do is we need to take the derivative. So you get g prime of x is equal to, and here you have to use the product rule. So the derivative of the first is 2x e to the x plus x squared minus 3 e to the x. The derivative of the second one times the first. So now we're going to do the little simplifying. G prime of x, just doing a little algebra. We're going to distribute in this e to the x right here. And you get plus x squared e to the x minus 3 e to the x. Now notice that all these three have the same e to the x, so we're going to factor that out. G prime of x is equal to e to the x 2x plus x squared minus 3. I'm going to do a little bit of rewriting to get e to the x squared plus 2 to the x minus 3. And now I'm going to factor. G prime of x is equal to e to the x plus 3 and x minus 1. The main reason I'm factoring is 1, it's always in good practice to factor, and 2, because we're going to set this equal to 0 to find our critical points. So we set each of these equal to 0. Now what notice right here, for this one, this can never be 0. So e to the x does not have a root. So we get this root of x equals negative 3 and x equals 1. So these are our critical points. So we're going to go ahead and do what we did in the last example and apply the first derivative test to determine maximums or minimums. So we go ahead and we draw a little chart, and we're going to plot our critical values of negative 3 and 1. And we're going to pick values in between. So I'm going to pick negative 4, 0, and 2. So now we just have to plug each of those into the derivative to determine if the function is increasing or decreasing. So let's do that now. F prime of negative 4 is going to be e to the negative 4, negative 4 plus 3, and negative 4 minus 1. So using this, I can determine positive or negative. Well, this is positive, this is negative, and this is negative. Which means if I have two negatives and one positive, the entire function is positive. So the function is increasing from negative infinity to negative 3. Now let's do the same thing with 0. You get f prime of 0, which equals e to the 0, 0 plus 3, and 0 minus 1. This gives us a positive because it's 1. This is positive, and this is negative. So you get a negative. And we do one more, which is f prime of 2, which is e squared, 2 plus 3, and 2 minus 1. Here this one's positive, and if you guess what's going to happen, all of these are going to be positive. So the whole function is positive. So we can see that we have a local max at negative 3 and a local min at 1. Now to figure out what those local max and local mins are, we need to actually evaluate them at the point. And I'm going to go ahead, I'm going to do that over here. So I get f of negative 3 is equal to negative 3 squared minus 3 times e to the negative 3. This is 9 minus 3 divided by e cubed, which is 6 divided by e cubed, which if you put that into a calculator, you're going to get roughly 0.299. Now we need to figure out our other critical value, which is 1. So you're going to get 1 squared minus 3 times e to the first. So this is going to be 1 minus 3 times e, which is negative 2e, which comes out to about negative 5.437. So now we're going to start drawing our conclusions. After all this hard work, we're going to draw our conclusions. So since f prime of x is greater than 0 from negative infinity to negative 3, and f prime of x is less than 0 from negative 3 to 1, 0.299 is a local max at x equals negative 3. Since f prime of x is less than 0 from negative 3 to 1, and f prime of x is less than 0, greater than 0 from 1 to infinity, negative 5.437 is a local min at x equals 1. Now what I want you to notice then is we need to look for absolute maxes and mins. So what we're going to do is we're actually going to graph our original function, and it's going to look something like this. Now you can see how the domain is negative infinity to infinity. Or not infinity, but yeah, infinity. But we notice how the graph really doesn't get any lower than right here. That tells us that this point right here is an absolute min. So all we have to do is go back here and change this from local to absolute. If you write absolute, it is also understood that it is also a local. And that's how you're going to do that. So this is how you determine max or mins using the first derivative test, which if you notice, this is what we've been doing all along. So now I want you to do is try one all by yourself. Try this one. I want you to determine max and mins of this function using the first derivative test. So take a minute, pause the video, and try it yourself. All right. Now that you've determined some max and mins, let me work it out with you guys and see if we got it right. So what we do is we take the derivative. If f of x is x cubed minus 3x squared plus 1, then f prime of x is 3x squared minus 6x. So we set this equal to 0. You get 3x is x minus 2. And we get x equals 0 and x equals 2. So now we're going to make the sign chart. And again, keep in mind the sign chart is not proof for an AP test. What you need to do is write out our conclusions, and that is the evidence. So our critical values are 0 and 2. So I need to pick some values on either sides of those. So I'm going to choose negative 1, 1, and 3. And we're going to plug those into the derivative to determine if it's increasing or decreasing. So f prime of negative 1 is going to be 3 times negative 1, negative 1 minus 2. And you can actually work this out. This one's not that bad, but I'm going to stick with my method. This is negative. This is negative. So the whole thing is positive, which means the derivative is increasing. F of 1 is going to be 3 times 1, 1 minus 2. This piece is positive. This piece is negative. So the whole thing is negative. So you get minus. So this is going to go down. And then we have one more. F prime of 3. This is going to be 3 times 3. 3 minus 2. So here we get positive. Here we get positive. So the whole thing is positive. So plus, and this is going up. So just looking at this, we can see that we have maybe a local max at 0 and a local min at 2. To find out the y values of the local maxes and local mins, we need to plug them back into our original function. So f of 0 is going to be 0 cubed minus 3 times 0 squared plus 1, and you get 1. So we get the point 0, 1. And we do the same thing with 2. F of 2 is 2 cubed minus 3 times 2 squared plus 1. And you get 8 minus 12 plus 1, which comes out to negative 3. So you get the point 2, negative 3. Now all we need to do is to write our conclusions. We have all of our info right here. It's not that bad. Now let's write our conclusion. Since f prime of x is greater than 0 from negative infinity to 0, and f prime of x is less than 0 from 0 to 2, then that means 1 is a local max at x equals 0. And since f prime of x is less than 0 from 0 to 2, and f prime of x is greater than 0 from 2 to infinity, negative 3 is a local min at x equals 2. This is what the AP test wants. They want to see this. Now we have to check for absolute maxes and absolute mins. So let's go back in our original function, which is x cubed, which we know is going to look something like this. So because the range is negative infinity to infinity, we don't have any absolute maxes or absolute mins.